Hey guys, today we are going to talk about a design pattern, namely the Singleton design pattern. First I'm gonna do a quick introduction into the pattern itself, where I tell you a few things about it and to what design pattern family it belongs to. Then we go over the two ways of implementing the Singleton design pattern and how these differ from one another. After that, I will be talking about the two main traits that an implementation of the design pattern must have in order to call itself Singleton pattern. When we are through with that, I will go over a few use cases for the pattern where it is most commonly used. Then, before jumping into our coding session in C#, I will be showing you a small diagram as to how the general implementation of the Singleton design pattern looks like. When we are through with all of this, we can go straight to Visual Studio 2019 and build a small example in order to see how the pattern looks like in code. Alright, let's get going. Okay, let's start with a quick overview. The Singleton design pattern belongs to the creational design patterns. As a quick recap, in software engineering, creational design patterns are design patterns that deal with the object creation mechanisms, trying to create objects in a manner suitable to the situation. The modeling of the Singleton pattern itself is actually quite easy to understand because it is nothing but a way of defining a class. There are actually two ways of implementing the Singleton pattern. They both have their ups and downs and their own individual use cases. Okay, so we've got two methods as to how to implement this pattern in a class. The first method is the early initialization. In this method, the class is initialized whether it is to be used or not. The main advantage of this method is its simplicity and that it is thread safe. The class is initialized at the time of class loading before anything in the program is actually happening. Its drawback is that the class is always initialized whether it is being used or not, which is something that we want to avoid in general. And the second method is the lazy initialization. In this method, the class is initialized only when it is actually required. This can save you from instantiating the class when you don't need it, which is what we as programmers would want. A drawback of this method, though, is that it is not actually good with multi-thread applications. In general, though, the lazy initialization method is most commonly used when we create a Singleton class. Now let's go over the two main traits that every implementation of the Singleton pattern should have. The first one is that it should have only one instance. This is done by providing an instance of the class from within the class. Outer classes or subclasses should be prevented to create the instance. This is done by making the constructor private in C# so that no class can access the constructor and hence cannot instantiate it. The second trait is that the instance should be globally accessible. The instance of the Singleton class should be globally accessible so that each class can use it. In C#, this is done by making a public getter for the instance property. Okay, now a quick rundown for a few use cases. The pattern is used where only a single instance of a class is required to control the action throughout the execution of the application. A Singleton class shouldn't have multiple instances in any case and at any cost. Singleton classes are most commonly used for logging, driver objects, caching, and database connections. All of these applications would just waste more resources if you were to create multiple classes for the execution of their jobs, since it can all be done with a single instance of the class. Alright, here we got a little diagram on how a proper implementation of the Singleton design pattern looks like. We can see that the Singleton class has got a private constructor which prevents any other class from instantiating the Singleton class. We can also see that the class has got itself saved inside a static object which is reachable through a static method. This static method is exactly what will be open to use for all external classes and clients. It will always return the same single object without ever creating a new instance of the class. Alright, let's get into the coding part. First we will create a new project. For this purpose we will use a console app.NET Core, because this is just a small demo, so we don't need to go anything big. Project name, we will just go with something like Singleton demo and go ahead and create this real quick. And yeah, this might take a moment, but I think it will be up fairly easy. Yeah. So the first thing we will do is just create a new class. This class, we will call it something like Singleton, because this will also be the class where we will implement the Singleton design pattern. First, we go ahead and put this to public, of course, so it's reachable from the outside. But now, before even implementing the pattern, first thing we will do is just create a new method that we will call something like hello world. And then this method will do not much, just a simple console output, hello world. Then we will go to the program, and just like we always do, we will create a new variable where we create an instance of the class Singleton that we just wrote. Okay, so now from this instance we can call the method that we just wrote, and we will see after building the solution, when we run the application, we will see that this, just as expected, will output hello world. Okay, now what do we do so this class actually implements the Singleton design pattern? For that, we will start off with writing a private Singleton property that we will call instance. Okay, so this instance will be set to a new instance of the Singleton class. But the most important part is this. We will write the constructor, but we will change it from public to private. This will of course also cause this part to crash. If we would try to build, you will see that it does not work since it's inaccessible due to its protection level. Okay, so how do we get around this? How do we keep the constructor private but make it accessible so that the only instance can be used? To do this, we will need to write another public method. This time, this method will return a Singleton object, and we will call it something like getInstance. Oh yeah, and both of these, of course, have to be static so that they are accessible globally. Exactly. Okay, so this method will do nothing more than just return instance, basically. So return this. What this will do is that when the application starts up, it will create this object, and since the constructor is private, this is the only time when this will ever be called. And when someone from the outside needs an instance of this class, they will have to use this getInstance method, which will just return this single instance. So now, so we can see this, we will do it here, Singleton dot getInstance. So this will call the method getInstance, and then we can see this will still work, build solution. And when we run the application, we see still the same thing, hello world. But the thing that changed now is that every time someone wants to use an instance of Singleton, they will use this method, and then by this method they will only get the same single instance of this class. Okay, but as I told you earlier, there are two ways of implementing this. So this was one way. This is basically the first way. There were two ones. The one was the lazy initialization and the early initialization. And as you can tell by this line, this is the early initialization, since this is instantly being called when the application is being started. So how can we implement the same thing in the lazy initialization, which is also the way that is mostly being used by people to implement the Singleton pattern? Okay, to do this, we will of course first get rid of this part, which is basically what causes this object to be initialized on startup. And what we will do then is we will write a few lines of code in here. If instance equals null, so that if this is still not initialized, then initialize it. So what we did is we basically moved this part that was here to here. And what it does is that only in the first time that this getInstance method is called, it will see, yeah, instance is still null, so I will initialize it. And then every time it is called, it will see, oh, it is not null, so I will just return instance. So there will be only one instance of Singleton here as well. But the difference is that here it is initialized when it's the first time that somebody calls this method, whereas in the method that we used before, it will always be initialized at startup of the application, which is the main difference of the two. This version right here is the one that is most frequently being used, so this is also what I would recommend using when talking about the Singleton pattern. Alright, this is basically it. That was everything about the Singleton design pattern. I hope you enjoyed this video and stay tuned for more.